Okay, we're going to take a look at finding trapped area, and in this case it's area between two curves or two equations. Now you're used to finding trapped area as a region trapped between a function and the x-axis, or another equation and the y-axis. So this is different. This is not area trapped between a function and an axis. It's area trapped between two functions. So here we have this one, which is an e to the x style function. We'll call it g of x. And then this is an upside down parabola. We'll call it f of x. We want to know how much area is trapped in there in the polka dotted region. And the first thing you have to know is you need to know the x coordinates of those intersection spots. So what I would do is I would go ahead and put that into your calculator, find those intersection points, and we'll unveil those here in a little bit. To get this trapped area, you have to have what I say is blind faith. And your blind faith is going to come into two areas, either upper minus lower or righter minus lefter. The upper minus lower is when you're going to do a problem with respect to the x-axis. The righter minus lefter is going to be when you do a problem with respect to the y-axis. So in this case, I'm going to do upper minus lower, and I'll explain why. If I do any slice of this region, like right here, or right here, or right here, or even over here, I'm always going from the upper function, which is f of x, down to the lower function, which is g of x. Every one of those slices is a distance between the upper and the lower function. So just so you understand why I wouldn't do righter minus lefter, if I started to do right to left slices, in this slice I would start at one function and I would slice over and end on the left with the other function. Well, that's all well and good, but if I continued slicing like that, eventually I would be up here and I would do a right to left slice, and I would start out on my f of x function, and when I ended my slice I would end up on my same function f of x. So the righter minus lefter would not work in this case because my slice originated and ended on the same graph. So upper minus lower, that's the way to go here. I just have to have blind faith in that. And so what I mean by that is this. As long as I know where the first slice is and where the last slice is, as long as I go upper minus lower, I'm going to get the amount of trapped area in there. Earlier I said you would need to get those intersection points, and here's what I have for those two intersection points. Now you notice that I went a little bit crazy and I went to midi-decimals, but remember, if your final answer is off on the third decimal place, then you don't get credit on the AP test. So rounding these early could easily distort that. But f of x is my upper function, that's the upside down parabola. G of x is the lower function. So that polka dotted area is really just upper minus lower integral. And there I have my final answer. It is as easy as that. Just use your blind faith in upper minus lower. Now you'd say, well, why am I making a big deal about just having blind faith? Here's why. I'm going to take the same region. So that region is now put down here. My drawing looks a little different, but what I've done is I've taken both graphs and I've translated them down by 6 units. So lower the y values by 6, lower the y values by 6, because this used to say minus 16 up there. So I took that entire region and I notched it down by 6 units, and now it looks like this. And for some reason, when the area that you're trying to find is straddling the axes, it's in different quadrants, people lose their faith in upper minus lower. But the same thing applies. If I just draw upper minus lower stripes, every one of those stripes represents an upper minus lower. pretty soon I've shaded in the whole region. And so now if I go ahead and do this, I have to do some adjusting here. If I go ahead and do this, upper minus lower, I remember I have a new f of x and a new g of x. I'm using these, but I still get the exact same answer, meaning the amount of area did not change even though the location changed. So don't be worried if that region is in negative territory, positive territory, negative x values, positive y values. It doesn't matter. Just upper minus lower is the way to go. It's really that easy. Okay, I've set up a new situation. I have two functions, function g, which is linear, function f, which is quadratic. And there's some area trapped between the two functions. Before I have any polka dots drawn, it would look kind of like this. So I want to calculate that area. And you would say blind faith and upper minus lower because you've been listening to this video. And that would work because if I draw stripes through here, I'll do it over here. If I draw stripes through here, every upper minus lower stripe originates at one function and ends at the other. So blind faith and upper minus lower works. I would need the x value that we started at and the x value that we ended at. And I would figure that out by using the intersection points on my calculator. So I've done this for you. There's the x value that we start at. There's the x value that we end at. And by the way, because I've traveled along the x-axis as I've made these stripes, I'm traveling along the x-axis. That's another way to remind yourself that this is really a dx question or a dx integral. So I've went ahead and unveiled the work. Here's the big picture, beginning to end, upper minus lower, blind faith. I work this out and I come up with the amount of trapped area. Well, let's take a look at this problem again. And if I look at it, I would say, hey, you know what? In this case, as opposed to the other case, I could also do my stripes going across. So stripe, 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 stripe. If I keep doing that, you'll notice that as I go through the entire region, every single stripe I was able to originate on the right-hand side on one function, in that case function f, the left-hand side function g. So I could do this as blind faith in righter minus lefter as well as upper minus lower. Now if I'm going to do blind faith in righter minus lefter, I have to know the y value that I begin at and the y value at which I end. Well, if I figured out these intersection points, I get x values and y values. So these y values tell me that I started at about, I'm going to abbreviate here, around 1.3, and I ended at 14.7. So now if I want to do this trapped area by righter minus lefter, blind faith in righter minus lefter, that's what the setup looks like. And by the way, I can just use the f of x and g of x. I don't have to write out the actual equations. And if I do this and put this into my calculator, and remember I wouldn't, I have to get back to that in a second. I'll talk about this step in a second. But before I get to that, my point is I get the same answer in righter minus lefter as I do upper minus lower, because in this case both of them had a valid set of stripes going across the whole region. Now if you take a look at this, you'd say, hey, those don't look like the equations that I was given, but here's why I have that. Remember, since I was going righter minus lefter, it's a dy problem because I traveled along the y-axis from here to here. First stripe, last stripe. This thing also tells you that y is the variable that you need to be using. Well, the original functions they gave us were with respect to x. So I had to do some algebra and turn this into an x equals and an x equals. On this one, I'm not showing you the algebra on here, but on this one I end up with y plus 1 over 3. And on this one I end up with square root of 2y minus 2. Just solving for x. Putting it in terms of y so that I can use the y variable in the integral. So, same answer, either way. So why didn't we do the righter minus lefter in the first example we just did? I think you probably picked up on that by now, but I'll go back and show you. As I talked about before, any stripes I did over here, right to left, these were valid stripes because they went from one equation to the other, but this example stripe right here was invalid because it started and ended using the same equation, and your integral will blow up in that case. You don't want an integral blowing up on you. So the key to these problems for you is just going to be to identify the region as either being an upper minus lower region or a righter minus lefter region. And in cases like the last example I showed you, either one would work. But there will be times that only this one works or only this one works. And you just proceed down that path. It doesn't matter where that region is located in the axes. Just have blind faith in that method. See ya.